All right, guys. Are there any questions on any of the assignments thus far? Any of the problems that y'all want to look at? So today we are starting chapter 7.5. So chapter 7, section 5. So we're going to cover part 1 today, and we're going to cover part 2 tomorrow and Wednesday. So part 2 will take 2 days because they're a little bit more intricate in the solving. The overall solving process isn't any real different than what we're doing today, but there's a little bit more to it that we need to delve into. So what we're looking at today is solving rational equations. And the first type we're looking at is the type where we have two rational expressions and we only have one on either side of the equation. Now, as we can tell here by the description, because it tells us example 1, solving a rational equation by cross multiplying. I do not like the term cross multiplying. It is a nice shortcut that gets very confused later on when y'all are not used to using it, because cross multiplication has some restrictions to how we use it. One is it has to have two fractions with an equal sign in the middle. We have to have two fractions with an equal sign in the middle to be able to use it. But we're going to look at it a little bit differently. Kind of like what we talked about on Friday with our complex rational expressions. We wanted the denominators to simplify out. We wanted to eliminate them. So if I was looking at the 9 over 4x plus 5, what would I need to multiply it by to simplify the denominator? What do I need to multiply this by? Would be what? What do we need to multiply it by to get the denominator to simplify out? So that would be 4x plus 5. Because if we multiply it by 4x plus 5, it would multiply by the numerator. And the numerator and denominator are the same, so they would simplify out. What would I need to multiply the 3 over x plus 1 by? X plus 1. But since we are talking about an equation, what I do to one side I have to do to the other. So for this side here, we'll have to multiply by x plus 1. And for the other, we have to multiply by 4x plus 5. Now for this first one here, I am going to write the whole thing out and then simplify. So for the one on the left, we're going to have 3 times x plus 1 times 4x plus 5 over x plus 1. On the other side, we're going to have 9 times 4x plus 5. Okay. Times 4x plus 5 times x plus 1 over 4x plus 5. Now again, whenever we have something divided by itself, they will simplify out. So here the x plus 1 and x plus 1 would cancel, leaving us with 3 times 4x plus 5 is equal to, well, the other side, our 4x plus 5 and 4x plus 5 will cancel out, leaving us with 9 times x plus 1. And what we just used was the least common denominator. We used a set of terms that when multiplied by everything in the equation will remove all of the denominators. Now we just need to solve for the value of x because we got all the fractions eliminated. So the first thing we can do here is distribute the 3, multiply 3 by 3 with the 4x and 5. Well, 3 times 4x is going to be 12x plus 3 times 5 is 15 is equal to. Here we can multiply through by the 9, and 9 times x is plus 9. Now that we have it here, what can we do next in solving? We can subtract what? We can subtract the 9x from both sides. Now we could have subtracted the 9 from both sides. Either one of those would work. Now if we subtract 9x from both sides, well, 12x minus 9x is 3x plus 15 is equal to, well, those cancels, leaving us with 9. Now what can we do? Now we can subtract 15 from both sides. 15 minus 15 would be 0, leaving us with 3x is equal to negative 6. 9 minus 15 is negative 6. And last but not least, we divide both sides by 3, which tells us x is equal to negative 2. And we get this here. Now, are there any questions on what we did to solve this here? Erase this here for a second. Highlighter. Now, with rational equations, we do have restrictions. We do have extraneous solutions that can pop up. And again, an extraneous solution is a solution, a value that we find for x that will not work in the original problem. Because if we look at this here, we have x plus 1 and 4x plus 5 in the denominator. So if our solution, our value of x that we find, makes either one of these 0, it will not work. We call it an extraneous solution. Because in these here, we cannot have the denominator be 0. So whatever value of x makes x plus 1 equals 0, or 4x plus 5 equals 0 would be our restrictions. And for these here, we can solve for the value of x. Well, the first one here, we can subtract 1 from both sides, telling us that x cannot equal negative 1. Because if x is negative 1, it would make the first rational expression have a denominator of 0. For the next one here, well, we can subtract 5 from both sides, telling us 4x is equal to negative 5. And if we divide both sides by 4, we get x is equal to negative 5/4. So if in this equation we had gotten that x is equal to negative 1 or negative 5/4, we would know that it's an extraneous solution. It will not work in the original problem. But what value of x did we get for the solution? Negative 2. Is either one of these restrictions negative 2? No. So that works just fine. Because if we got a value of negative 5/4 or negative 1, we know that those solutions cannot work because negative 1 and negative 5/4 does what? It makes what equal 0? What makes these here 0, yes? But where are they? They're in the... And if the denominator is 0, well, we have a division of 0, and that does not work. We cannot divide by 0. Any questions on this here? Okay. Well, let's look at this one here. Now, we ended the last one with our restriction, so we can go on and start with that here. So we want to see what will make the denominator 0. So it's here is really looking at these two here. What's going to make x plus 2 0, and what's going to make 3x plus 2 0. Because those values of x will not work. So negative 2. because what's going to make x plus 2 0 is negative 2. As x plus 2 equals 0, well, to get x by itself we would subtract 2 because 2 minus 2 is 0. So x cannot be negative 2. We could do the same thing with 3x plus 2. Well, we would subtract the 2, so saying that 3x is equal to, and then, so x would equal negative 2/3. So our restrictions for this here is negative 2 and negative 2/3. So if our values of x show up as either one of these here, we know that solution will not work in the original equation. It does not work because it gives us a denominator of 0. We cannot have a denominator of 0. We cannot divide by 0. Okay. Let's go on and work this equation here. So the first thing we need to do is really to get these fractions to simplify away. Because if we don't have to worry about the fractions, we can go on and solve for the value of x a little bit easier. So what would I need to multiply the 10 over 3x plus 2 by to get the denominator simplify out? Well, 3x plus 2. And what I do to one side, I have to do to the other. So the 2 over x plus 2, we need to multiply it by what? X plus 2. Now we do need to make sure that we're not multiplying by more than what we absolutely have to, because if only one of these is necessary, then that's all we need. Because here, how many times does x plus 2 appear in any of the rational expressions? So we only need it. Right, because if one of them had x plus 2 times x plus 2, we would need it twice. Even if both of these were x plus 2, they only appear how many times? So we would only need it once. Because anytime we add an extra, especially x plus 2 or an x, a variable, we increase the degree of what we start solving by 1. Which in this case wouldn't be too bad because it would take it from a linear, where the biggest exponent with x is 1, to a quadratic where it is 2. But if the equation would have worked out to be a quadratic, it would have taken it from a quadratic to a cubic of degree 3. Degree 4, we keep increasing the degree with each extra one we add. And it's just adding extra zeros that are repeated. Okay, any other questions on this here? Yes? No? Now on the last one, I did rewrite it out. We don't have to do that step. I did it so that we could see the simplification. Now if we look on the left, well, the x plus 2 in the denominator will cancel out with the x plus 2 that we're multiplying, which will only leave us with what? 2 times the 3x plus 2. On the right-hand side, the 3x plus 2 in the denominator will cancel out with the 3x plus 2 in the numerator, leaving us with 10 times x plus 2. And with most of these here, when I do the steps for simplifying, I will write it out with that multiplication to remember what we're multiplying everything by, and then just go on and cancel. I don't rewrite it out. Now what we can do next is to distribute. Our 2 times 3x would be plus 2 times 2 would give us 4. Here we would do the same thing with 10. 10 times x is 10x plus 20. Yes. Now what can we do next? We can subtract 6x from both sides. Because here 6x minus 6x would be 0, leaving us with 4 is equal to 10 minus 6x is 4x plus 20. And we could have subtracted 4 from both sides, or 20 from both sides, or 10x from both sides. Any of those would actually get us to the correct answer. It's just depending on how you want to do it. But once you do that first one, it kind of tells us what we have to do next. Because here we would have to subtract 20 from both sides. And if we subtract 20 from both sides, it tells us that 4x is equal to negative 16. And last but not least, we can divide both sides by 4, telling us x is equal to negative 4. It is negative 4, one of our two restrictions? No. So that is the solution to this here. If it asks for them, it is good. Here, the ones we're doing today, the restrictions aren't a huge deal because they're not coming up. Because the solutions that we have will not be one of the restrictions. But once we start solving them, where the restrictions could possibly show up, we'll have to start using those. Now, the nice thing with restrictions is, well, finding these two values on the most part isn't overly difficult or complicated to get to. Would y'all agree with that? Because it's just setting the denominators equal to 0. Now, when they do come into play, if we have already solved the restrictions, well, it's really just saying, did one of these two values show up as our solutions? Yes, it means they don't work. No? Okay, we're fine, because they didn't show up here, so it works. Now, the other thing is if we don't find those, because we found out x is negative 4, what we would need to do is with every solution, come back in here, plug them in, and check to see if they worked or not. So by just having the restrictions, we already know if one of the values matches it, we can throw it out. It doesn't work. Because if we plugged it back in, okay, we would see that it doesn't. Here, if I check it, well, negative 4 plus 2 is negative 2. Here, 3 times negative 4 is negative 12 plus 2. Well, 2 divided by negative 2 is negative 1. Well, negative 12 plus 2 is negative 10, so it tells me negative 1 is equal to negative 1. Both sides are the same thing, so that is a solution. So when we have extraneous solutions, we need to be checking to make sure, okay, do both sides give us the same thing? Do we have a number that makes the denominator 0? We have to be plugging them back in to check to see if they do work. Any other questions on this here? If it cancels out all. So here, in the last ones, we've only had 1. So if that 1 matches up with the restrictions, then yes. I don't have any solutions left, so it would be no solution. So if all the solutions are eliminated out by restrictions, then it would be no solution. But it doesn't actually work. Any other questions on this here? Okay. Let's look at this last one here, and then we'll move on to the next type. Well, we can look at the restrictions here, and I think the restrictions for these two are a little bit easier to see than the last ones. Because the restriction for 5x, what times 5 makes it 0? Well, 0. Because if we have a variable and a number being multiplied but no addition, subtraction at all, well, it has to be 0. Even if it had been 5x squared, it's still going to be 0. And so x minus 7 would be because 7 minus 7 is 0. Luckily, those two aren't bad. So if we get a solution of 0 or 7, we know that either one of those would not work. Okay. Okay. What would we do first? We multiply both sides by what? Yes. X minus 7 and 5x. So we're going to multiply everything in this equation by 5x and x minus 7. And the reason we do this is because for our 1, here the 5x and 5x would cancel out. And the other one, the x minus 7 and x minus 7 would cancel out, leaving us with here, well, it's going to scroll apparently, 3 times x minus 7. So we don't have any fractions left. And the other one we're left with 2 times 5x. Now, if you do feel comfortable going and multiplying those together instead of rewriting them out like we did, that's fine. Because we could have gone on and jumped on to, well, 3 times x is 3x. Apparently it's going to continue to scroll. Minus 21. Because 3 times x would give us 3x, and 3 times 7 would give us 21. On the other side, 2 times 5x is 10x. Well, now we just need to solve for the value of x, which means we can do what first? We can subtract 3x from both sides, which would tell us that 7x is equal to negative 21. And last but not least, we can divide both sides by 7, telling us x is equal to negative 3. And again, that's not one of our restrictions, but that's all we need to do on this here. Any other questions on any of this here? Do we need to see another example of one of these? Okay. Because I do have more of these, but if we do feel comfortable, we can move on to the next type. Because they're not any real different, it's just the numbers change a little bit. Solving rational equations by using a least common denominator. Now they change it from cross multiplication to least common denominator because, well, I don't have one rational expression on either side. Because on one side I now have 2. So if I wanted to use cross multiplication, and it is possible, I would need to actually add these 2 fractions together so that I do have one fraction on either side, and we can cross multiply. But that's unnecessary. Because what we can do is actually use the least common denominator. What we've been doing on the last ones to actually solve this. So what we want to do is multiply each of these terms by a certain expression so that the denominators would simplify. So the negative 9 over x, we would need to multiply it by x. And the 5 over x would also need to be multiplied by. But what we do to one side, we have to do to the other, so we're going to have to multiply everything by x. So we're multiplying the entire equation through by x. Do we need anything else? The 4, because the 4 is also in the denominator, yes? So we'll also need to multiply everything by 4. So we need to multiply each of these terms by 4x. And if we do this, let's see what happens. In the first one, well, we're going to have 5 times 4x over x plus we'll have 7 times 4x over 4 is equal to negative 9 times 4x over x. Now in our first rational expression, well, the x and x cancel. And the middle one, well, the 4 and 4 would cancel. And in the last one, our x and x would cancel or simplify out. And what does that leave us with? Well, in the first one, we are just left with 5 times 4, which is 20, plus the middle one would just be our 7x, because 7 and x are the only thing that's left, is equal to negative 9 times 4 is 36. So multiplying everything by 4x actually simplified all the denominators, leaving us with this here. Now what would we need to do next? Subtract 20 from both sides, yes. And if we subtract 20 from both sides, we're left with 7x is equal to negative 56. And last but not least, we would divide by 7, telling us x is equal to negative 8. And that's it. Now, again, we didn't look at the restrictions. Where are the spots where we could have a denominator of 0? 5 over x and 9 over x, yes? Because the 7 over 4, well, there's not a variable in the denominator, so I can't actually make it 0. So we're really looking for what value of x is going to make those two spots 0. Well, x cannot be what? 0. Since the variable is by itself, there's nothing added or subtracted or powers with addition, subtraction. It's just 0. Well, we do know that negative 8 is not 0, so we don't have any restrictions. Any solutions that would be a part of the restriction. Any questions on any of this here? All right, let's look at this one. Let's look at this one here. So again, we need to simplify the denominators. So what can we multiply each of these terms by to get the denominators simplify out? So we'll need an x for the 3 over x, and if we multiply it by one thing, we have to multiply it by everything, and the x minus 5. And again, I've realized I've not talked about the restrictions, but we'll leave it to the end at this point since we already got started. Now, if we do the multiplication of x and x minus 5 across these 3 here, well, in the middle, the x minus 5 and x minus 5 will cancel out like we wanted. And at the end here, the x and x would simplify out, leaving us with, in the first, well, x times x minus 5. We don't need the 1 because 1 times x is just x. Minus, well, in the middle we would have 8x is equal to 3 times x minus 5. Now, luckily we did, by multiplying everything by x times x minus 5, all the denominators did simplify out, and we're left with this here. Now we need to distribute. So the first one will distribute the x. So x times x is x squared minus 5x minus 8x is equal to, here we'll distribute the 3. 3 times x is 3x minus 15. Now we can go on and combine like terms because there are two like terms here, the negative 5x and negative 8x. And negative 5x minus 8x is negative 13x is equal to 3x minus 15. But looking at this here, the degree of this function is 2 because we have an x squared. So that means it is a quadratic. And whenever we get a higher degree polynomial, we need this thing equal to what? 0. Because when we solved quadratics last semester, we got everything on the same side and set it equal to 0. When we talked about higher degree polynomial functions, we got everything onto the same side and set it equal to 0. So what do we need to do next for this here? Well, we need to get this thing equal to what? 0. So what can we do first? (3x) by subtracting 3x from both sides. So here we would have x squared minus 16x is equal to, well, 3x minus 3x is 0, negative 15. Then what can we do? Add the negative 15 or add 15 to both sides. So we could subtract the negative 15 or add 15 to both sides. And what that would give us is x squared minus 16x plus 15 is equal to 0. So at this point here, we do need to solve this here. Now we can solve this by factoring or the quadratic formula. Which one do y'all want to use? We can try to factor it. 2 sets of parentheses equals 0. Since the 15 is positive, the signs are the same and they match the sign of the middle term, which is negative, so negative and negative. Now the factors of x squared are x and x. Now we need to look at the factors of 15. So we have 1 and 15, 3 and 5. Which one would we want to use? 1 and 15. And it does work out that these here, x minus 1 and x minus 15, are the factors of x squared minus 16x plus 15. And we get to this here. Now at this point here, I do have two things multiplied together that equal 0. What is the only number that I can multiply another number by and get 0? There's only one. 0. So if I have two things multiplied together equals 0, it means one of them has to be 0. So what we're saying is that either option 1 now, x minus 1 is 0 or x minus 15 is 0. Because when we solve by factoring, we factor it down and then set each of the parentheses equal to 0 and solve. So for the first one here, x minus 1 equals 0. Well, the first thing we can do is add 1 to both sides, which will tell us that x is equal to 1. And since x by itself, one of the solutions for this here is that x is equal to 1. What can we do with the other one? Add 15 to both sides. These would cancel, telling us x is equal to. So our two solutions here is that x is equal to 1 and x is equal to 15. And that's it. Now looking back here, because we didn't talk about the restrictions for the two denominators, but the values of x that we cannot have, for this one here it would be 0, and for x minus 5 it would be 5. So if we came up with 0 or 5, those solutions would not work in our original equation. But the solutions for x that we got were what? 1 and 15. Are those either one of our restrictions? No. So both of these answers do work. Any other questions on any of this here? Now the rest of these here are the exact same as what we just did. They just have different numbers for their solutions. Are there any other questions on anything we've done today? Okay. If there are no other questions on any of this here, we are finished with 7.51. So your homework is on page 406 through 9 and 19 through 22.